Okay, hey, let's look at example problem 7.2 now from the book. We are going to draw shear and bending moment diagrams for the beam that we're shown here. So let's actually, I'm going to go ahead and let's lay them out right here. And that's not the color I meant. Let's grab the black. Okay, so let's lay them out right here. And what we're going to do is here, this will be my shear, and this will be my bending moment diagram. Okay? And so what we need to do is we're going to go through, we're going to say slice it like right here, and then right here, and right here, right here, and go through and take a whole bunch of slices as we move along. And we're going to look at the shear and the bending moment at each one of those points. So before we can do any of this stuff, we need to figure out what the reactions here are here, and that actually I do want, let's go back to red because it makes life easier. We want to calculate what this and this force are. So that one's pretty straightforward. Let's do the sum my moments at, say, D is equal to 0. So we have 20 times 2.5 plus 3 plus 2, so 7.5, plus 40 times 2. Those two are going to make it rotate in that direction, and this is the B is going to make it rotate in that direction. So this is equal to B times 5. So therefore, B is equal to, turns out to be 46. And then if I take my sum, my forces in y equals 0, it's going to tell me that D is equal to 14. Okay, so I'm just going to go ahead and just write those. This is 46, and this is 14. Okay, so there we go. Now we have our nice simple beam, right? So I'll draw this over here. Yeah, again, I think it's going to work better like this. And draw a straight line, a beam. So I have 20 coming in here. Here a little bit later, I have 46 coming up there, and then 40 coming down there, and then 14. Okay, so that's what we're dealing with. So now let's look at this point, like kind of just right here. We'll just cut it off super close. So we're going to have this little beam. We have 20. Now, when we draw this, let's draw the shear and the bending moment in the positive sense, right? So I have V and M. Okay, so how do we do this? Well, first off, sum my forces in y equals 0 tells me that V is equal to minus 20. Okay, so right here, I'm going to put a little mark here. This is minus 20. So here, that's kind of our starting point right there. And what about the moment? So if I take my sum my moments at point A, remember this is point A right there, equals 0. So if I'm super, super, super close to this, then my lever arm is basically 0. So my moment is roughly 0. So I'm going to be starting there. Okay, so now let's take, so that was taking it like right here, right? Let's take it a little further into it. So we got 2.5. So let's take it at 1 away. So we're going to have now this little beam. I give myself a little more space. I have this beam. I have 20 coming in here. And if I have a fairly short beam, so I have V and M, whereas this distance is now 1. Okay, so sum my forces in y equals 0 tells me that V is still minus 20. Okay, so that's maintained. So I created this slot, right? Did this dot, that dot, now that dot. And the moment, let's look through the moment. So my moments at A equals 0. Well, so I have minus 20 times 1. So that's right. And that's going to make it rotate in that direction. So I need to counteract that equals my moment. So my moment is minus 20. Okay, fair enough. So at 1, so if this is basically lined up, so now we're looking kind of here-ish, right around here. It started here, now it's at minus 20. I didn't give myself quite enough space here, so don't tell anyone. And let's put this spot right there. Okay, so now let's take it, let's keep going. Let's go say right here, right before B. So now we have, we'll go 2.5, but we'll do 2.5 just on this side, right? So I still have a force here of 20. I have my V and my M. Sum of my forces in Y equals 0 tells me that V is equal to, hey, who knew, minus 20, so that hasn't changed. So we're going to come down here and at this point, okay, so I'm still at minus 20 right there. If I take my sum of my moments at A equals 0, so what does that tell me? Now I have my minus 20 times that whole distance, which is 2.5, is 2.5 minus just a little bit, so it's just on the left side of that B thing, right? That's equal to, that's a 5, it looks like a 3, there we go, is equal to my moment. So my moment at this point is 20 times 2.5, what is that, minus 50? Okay, so this is down here at minus 50. So this is minus 50. Okay, and if you go through and you do it, you can see this is just holding a straight line right through here. This is actually just kind of a nice linear thing through there. Okay, so now let's take it just on the other side. So let's look at this point right here, right? So now I have this beam, right? I have a force down here of 20, but now I have a force here of 46. And if I cut this off, I have a V and a M. So sum of my forces in Y equals 0 tells me now that V is equal to, what, 26? It's a positive 26, so this also bumps up here to 26. Boom. And I have a point right there. And let's look at the moment at that point. Let's take some of the moments at A. So now what do we have? Now, at this point right here, we have the 46 times, what, 2.5? And that's going to go in that direction. Sorry, get rid of that one. Oh! Don't tell anyone. Plus my moment, which is also in that direction, right? Now my V, so it's going to be minus V times 2.5. And what is V? We figured out it's 26, so this I'm just going to replace this with 26. So therefore, if we factor that out, hopefully it'll make the math really obvious, is equal to 0. So 2.5 and 46 minus 26 plus M is equal to 0. So M is equal to minus 2.5 times 46 minus 26, which is 20. Which you'll notice is the same thing that we got right here, right? So this is still equal to minus 50. So yeah, it's just this point. It hasn't really changed. Oops, sorry. So now let's go through and let's push it a little further. Let's consider this point, like right here. So halfway. So now we're going to have this beam. Boom. We have 20 coming down here. At this point, we have 46. Now we have V, M. Okay, so take my sum of my forces in Y equals 0 is going to tell me yet again that V is equal to plus 26. Yay, yay, yes. Hasn't changed. Okay, so as we see, I can go through and it's out to here. But now we're talking, so like halfway through there, so at 1.5. So now let's take the moment. Say the sum of my moment at A is equal to 0. Okay, so in that case we have 46 times the distance, which is 2.5. Right, so this distance, that's going to be going in that direction. So minus V times, now if we are talking about halfway, 2.5 plus 1.5, so what is that, 4? Minus times 4, and then plus moment is equal to 0. And we know what V is, right? V is 26. So therefore, let's plug in some of those numbers. We got 46 times 2.5, and then 26, oops, I goofed this, 46 times 2.5, right? And then 26 times 4, and take the difference between those two. So the moment at this point is equal to minus 11. Okay, so here it's come up to like that point right there. Okay, interesting enough. I can draw a line there. Let's go through and take it at point just before point C. So if we're looking at just before point C, sorry, it's getting kind of messy. We will show you little cleaner, faster ways to do this, but this is a good exercise. So we're going to have this same thing. We have 20 coming down here. We have 46. We have V and M. Okay, so sum of my forces in y equals 0 tells me that V is still 26. Yeah, yes. Okay, so that's, now we're talking to this point right here. So this still hasn't changed. Lovely. Okay, now sum my moments at A equals 0. So I have 46 times 2.5. That hasn't changed. And then it's going to be minus V times, now we're looking at, again, this point right before here. So what is that? 5.5? 5.5 plus M is equal to 0. So now M is equal to, as you go through 46 times 2.5 and 26, because V is 26, times 5.5, and you take the difference between those, and you have moment is equal to positive 28. And that is, so that comes up here, boom, straight line up to this point right here. So this is 28. Okay. So now if you take it on the other side of this, just on the other side, let's come in here. Now we have 20 coming up, 46. Now we have 40, right? Then you could have a V and an M. And so if you go through, you take your sum of your forces in y equals 0, it tells me what V, in this case, is going to be, now it's back to, what, minus 14? Minus 14. So this is going to drop to here. And if I take my sum of my moments at A is equal to 0, you're going to find that this is still equal to, so just, it's, I haven't really added any lever arm. I've added this, but then I've changed this. Well, let's just do it. We have 46 times 2.5 plus V times, now we're looking at 5.5 plus a little bit, 5.5, right? But that's going to be, sorry, not plus, that's going to be negative because that's going to be working against it, minus V. Now, that's going to be going, now it's also going to be minus 40 times 5.5. And that is going to plus M equals 0. Okay, sorry for the mess there. So therefore, we get 46 times 2.5 and V, which is minus 14. 14 times 5.5. So those end up being, that ends up being a positive, right? And then 40 times 5.5, and you subtract that, and we get, hey, who knew? Moment is equal to plus 28. So in other words, just on the other side of here, it hasn't really changed. It's right there. Okay, so let's do one more. Let's kind of come through the middle section there, and what are we going to get? Have the same beam. Oh, sorry, this line is getting less straight as we go along. 20, 46, 40. Now coming to here, we have V and M. So sum of my forces in y equals 0 tells me that V is, surprise, surprise, minus 14. No change there. Now what about M? So, you know, it's going to be, if I take my sum of my moments at A equals 0, so I'm going to have 46 times 2.5, right, minus 40 times 5.5, right? And then it's going to be minus v times, so now if we're considering this point like right here, so now we're talking 2.5 plus 3, so 5.5 plus 1, 6.5. So minus v times 6.5 plus m is equal to 0. So in this case, m is going to be, let's put this at 46 times 2.5, and then 40 times 5.5. So let's go to subtract that. And v, which is minus 14, so 14 times 6.5. Okay, so add those up, and therefore moment is equal to minus 14. Sorry, not minus, it's equal to plus 14. So coming to here, this is come back down here to like, so we figured out this is here, and now we're talking like here-ish. And then lastly, let's go to this point right here, right at D. Okay, so now this last one, we have this beam here. We have 20 coming up here, 46 coming down here, 40, and then 14. So if I shear this here and do my moment, so if I do it just on the other side of that 14, anyways, you'll see, remember V was 14. So now if I do my sum of forces in y equals 0, V is equal to 0. So it's going to come, so if I do it, before I do this, let's do it just before that point, right? So just before, so here's this, but I'm going to do it right here. So I'm going to have V and moment. So V is equal to still minus 14. And if I take my sum of my moments at A equals 0, what am I going to have? I'm going to have 46 times 2.5 minus 40 times, excuse me, 5.5. In this case, minus V times, let's look through this, this is minus all the way over to here, right? So we're talking 5.5, 7.5. 7.5 plus m equals 0. So therefore, you'll find that m is equal to 46 times 2.5, right? And then 40 times 5.5. Subtract that off. Now v is minus 14, so 14 times 7.5. And then you get, lo and behold, moment is equal to, 0. So what that's saying is this thing comes all the way back down here to 0, whereas this maintains here. And then at the end, which I just showed kind of on accident, once you consider this last point, just you have 20, 46, 40, 14. If you look just after that point at your V and your M, V is equal to 0 at that point. So that is it. Boom, 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 boom. And here, just to kind of make it a little more obvious what's going on. That is your shear moment diagram. Here is your bending moment diagram. And that is the answer. It's actually not hard. It's just a lot of little individual steps. You can start to learn some lessons. You'll notice like from here to here to here, this ended up being a straight line. So in reality, probably in the future, you can start to realize, hey, let's take it maybe like right here and right here and right here and here and here and here and here. So you don't have to do as many steps as we did, but that's the process.